Compare real numbers. Right, this is the thing we've been building towards. So let's start with this graphic organizer here. We have a bunch of number sets, and knowing what the number sets are matters so that when we communicate to each other we have an understanding of what we're saying. Like our first number set we're going to put in here is whole numbers. Whole numbers. And what that is numbers that we can count with our fingers. So 1, 2, 3, 4, 5. But that also includes zeros. So 0, 1, 2, 3, ... And that goes on forever. One step out from whole numbers is integers. I-N-T-E-G-E-R-S. So integers are all the whole numbers and then their opposites too. So we have like -3, -2, -1, 0, 1, 2, 3, all those going off into infinity left and right. We take one step further back, and now we have a bigger pool now, and that's rational numbers. Rational numbers. All right, and remember, rational numbers are a comparison of two numbers, so that would be, or a comparison of two integers, sorry, where b does not equal 0. So anything we can write as a fraction. So that is like percents, decimals, repeating decimals, fractions, mixed numbers, improper fractions. All those are rational numbers. Then what we introduced recently, which was roots, we started talking about roots, and we knew that roots don't always go with perfect squares. So what we have here then is also irrational numbers. That's a double R. Irrational numbers. And in irrational numbers, what we're talking about is something like the square root of 7. So the square root of 7 cannot be written as a ratio, which makes it irrational. It's a number that repeats itself, but doesn't repeat itself, but keeps going on forever. There's some special cases for irrational numbers too. We have pi, of course. We're all familiar with pi. That being 3.1415 ... Oh, my nose is itchy. And then we have something about these. Wait. Nope, the tingle's going away. I'm winning the battle. No, it's coming back. No, it's going away. All right, I think it's gone. Then we have another number that's called, it's written with the letter E, a cursive E, and it's called Euler's number, but Euler's is spelled like Euler. And that's a number similar to pi, and that's 2.71, 8281, and that keeps going on forever. That's an irrational number too. And then to put this all together, like we go back here and say, compare real numbers, what we've just created is the graphic organizer for all real numbers. So these are the real numbers. Before we start comparing these numbers, let's actually identify what they are. So I have some examples here. But what I'm going to do is I'm going to mark off in this matrix what types of numbers these are. So let's start with the first one here. The first one says 0.3737 and then ... That's the same as saying 0.37 repeating. It's just another way to write that. So when we look at that, is that a whole number? Could we count that with our fingers? No. Okay, so it's not a whole number. Is it an integer? Which means, is it a whole number or an opposite of a whole number? No, it's not that. Is it a rational number? Could we write this as a fraction? Well, yes, we could. If we go all the way back, we know that the fraction for this is 37/99. And if it's rational, that means it can't be irrational. So this one only falls in the rational realm. How about the square root of 49? Well, the square root of 49 we know is equal to 7. Is 7 a whole number? Yes, it is. Is 7 an integer? Of course. If it's a whole number, it has to be an integer too. Is 7 a rational number? Of course it is. Because we can write it as 7 over 1. Is 7 irrational? No. It can't be irrational if it's rational as well. How about the square root of 8? Ugh. All right, that's not a perfect square. So that means we have a decimal that isn't that we can't write it as a fraction. It's not a whole number. We can't count it with our fingers. It's not an integer. So that is an irrational number. Then we got -8/4. Now you're looking at that going, all right, I don't know about that. Well, let's just simplify that to -2. Now let's look. So is -2 a whole number? No, it's not a whole number because we can't count it with our fingers, and it's not positive. Is it an integer? Yes, it's definitely an integer because it's the opposite of a whole number, which would have been 2. Is it a rational number? Of course it is, because we can write it as the fraction -2/1. Is it irrational? No, it can't be irrational if it's rational. Comparing real numbers means we need to put them in the same form. So what we're going to do is let's convert them all to decimals so that we can check to see which ones are greater or less than the others. So just starting with this simple comparison here, we're going to try to get those alligator teeth in here. So is it less than or greater than or equal to? So I've got square root of 6. So I punched square root of 6 previously into my calculator, and what I found was the square root of 6 is 2.449. That does keep going. And let's rewrite 2.5 as a decimal, so we know that's 2.5, right? So we got 2.449, keeps going, and 2.5. Let's just look at the tenths place here. I got a 4 and a 5, which means this is, the 2.5 is greater than the square root of 6. Now, for a number set here, now I've got 4 numbers here. Let's look and see what these are. I did not previously do my square root of 31, so I'm going to do that right here with my handy dandy calculating machine. So I'll do second function x squared 31, close parentheses, and say that the square root of 31, so I'm going to write the square root of 31, is 5.567. I'm going to stop there because I'm just going to say, let's go to the thousands place and see if we can compare it that way. Then I've got 6, and we know 6 is 6.000. Then I've got 5.39, and that's just going to write as 5.39. And 5 4/9. Okay, do you remember 5 4/9? That 4/9 means a repeating decimal because of that 9 in that denominator. So that 5 4/9 is going to be 5.4 repeating. Now, if we put these in order from least to greatest, let's look and see here. The 5.39 is the least. Then the 5 4/9. Then the square root of 31. And then 6. And now we took that number set. Oh, my curly brackets aren't so good. We took that number set and we turned it into, put it into the order of least to greatest. Vocabulary! No. Vocabulary! All right, things that we picked up in this one, stuff that we knew. We knew whole numbers, we knew integers, we knew rationals. Let's just throw rationals up here, though, because rationals will help us understand what an irrational is. So we have a rational number, which is any number that we can write as a comparison of two integers, which we know those are. And an irrational is anything that cannot be written as a comparison. Oh boy, I hope you're going by my words because my writing is kind of falling apart here. Of two integers. Lastly, though, let's get this in here too. Let's not forget this fancy new number set that we have now. Real numbers. And that is any rational or irrational number. R. There we go. Great. All right, guys. Good luck.